Hello, ladies and gentlemen, and thank you for joining me as we continue our look at the 2011 Manitoba Math Contest. We're looking at question 5 in this video. If you're interested in questions 1 through 4, of course, those are previous videos, and if you tried the contest, as I often encourage you to do, and you're looking for later questions, those will be posted eventually, in the near future. But right now, it's all about question number 5, so 5A. The sides of a rectangle are as shown. Okay, we've got some expressions in x and y. Find a numerical value for the area of the rectangle. Interesting. Numerical value for the area of the rectangle. Let's copy this rectangle down. Now, because it's a rectangle, we're going to exploit the fact that opposite side lengths are the same. So we have x and 2x, x and 2y. Immediately I can say x is equal to 2y. Then we have these other expressions. It was x squared, I think it was minus 12x, and then it was y squared something something. X squared minus 12, and it was 3y squared, and I think it was a minus y, if I caught it correctly. Yeah, okay. So x is equal to 2y, and x squared minus 12 is 3y squared minus y. Now, they didn't tell me anything like they have to be positive integers, right? Nope, okay. So x is 2y. I'm going to take this really quickly, plug it in here, so we're going to have 4y squared minus 12 is 3y squared minus y. Quadratic, we'll bring everything over to one side. Y squared plus y minus 12 is equal to 0. So we can factor that. Y will be either, so multiply to negative 12, add to 1, it will be plus 4, y negative 3. So y is either negative 4 or 3. Y is not negative 4, since 2y is a length. So y is going to be 3, x is going to be 6, but we don't need these numbers. Well, I mean, we do need them, but they're not our final answer. Our rectangle now must look like 6, and then 6 squared minus 12, so 36 minus 12, so 24. We can just do a double check. 3 times 9 is 27, minus 3 is also 24. So the area is 6 times 24. I don't know why I wrote 64. Take a 2, put it to 12 times 12, so 144. And that's going to be our final answer for first part of 5A. 5B, prove that for every positive integer n, the number n cubed plus 2n is divisible by 3. Okay. So, any integer n leaves a remainder of 0, 1, or 2 upon division by 3. So that tells me n equals either 3 times k, 3k plus 1, or 3k plus 2. Now this is less common than the one that you should be familiar with. Every even number can be written as 2k, which is really 2k plus 0, and every odd number is 2k plus 1. But you can do that with really division by any number. Okay, so we have these 3 cases. All I'm going to do is evaluate the expression that they gave me for each of these cases and show that it's just going to be a multiple of 3. That's all, and that's enough to do this. Okay, so if n is 3k, and then what was the expression? N cubed plus 2n. N cubed plus 2n is then 3 to the k cubed plus 2, 3 to the k. So this is 27k cubed plus 6k. All I need to do is take a factor of 3 out. So it's 3 times nk cubed plus 2k. And that's a multiple of 3, because I wrote it as 3 times something. Okay, if n is 3k plus 1, then n cubed plus 2n, these are going to be the harder cases. So 3k plus 1 cubed, you may need to FOIL it out a little bit, but you're going to get 3 times, and then, so it'll be 27. 9 times 3 is 27. 27k squared plus 3 times 3k, so it'll be 9k, plus 1, and then plus 6k plus 4. No, this isn't a plus 2, it's a plus 1. I'm going to say 1 plus 4 is not a multiple of 3, but 1 plus 2 is. So we can write this as 3 times 9k cubed plus 9k squared. Combining these two is 15, so 5k plus 1. And that's a multiple of 3. And now the last one. If n is 3k plus 2, n cubed plus 2n is 3k plus 2 cubed plus 2 times 3k. Now here's the plus 2. And this is 27k cubed, and then 2 times 9 is 18. 3 times that is 54. 2 squared is 4, times 3 is 12. 3 times that is 36k. And then 8 plus 6k plus 4. Now I can take out factors of 3 everywhere, so 3, 9k cubed plus 18k squared plus, it would be 12, but we add a 6 to it, so it's going to be 14k. And then 8 plus 4 is 12, take out a 3 is 4. So 3 divides n cubed plus 2n, since we covered every single case. Okay. So because they were asking me for divisibility by 3, I essentially did the problem modulo 3, or working solely with remainders when we divide by 3, because that's all that mattered. No one cares what k is, and 3k, of course, that's divisible by 3. It's all about the plus 0, plus 1, and plus 2, and you just have to show that each case gives you divisibility by 3. There are other questions out there. There are good ones with divisibility by 5. I wonder if there was a cleaner way to show this. So if they had something like n cubed minus n, you can show that that's divisible by 3 really quickly by factoring out an n minus 1, an n, and an n plus 1. And this is 3 consecutive numbers. One of them is a multiple of 3. So that's a fast way to do that, but factoring this one would get n squared plus 2. It's not immediately obvious that n squared plus 2 is... so n is, if n is divisible by 3, then yeah, this is divisible by 3. If n isn't, n squared leaves a remainder of 1. That's something you could show. So 1 plus 2, that would be multiple of 3. That'd be another way to go at it. But in general, this technique would always work, or it should always work. Figure out the remainders and then do cases based on each possible remainder. Alright, so that wraps up question number 5, and that means we are halfway done the contest, at least numerically. The final 5 questions should be harder, so we should devote more time out of the 2 hours to them, but you know what? We can still celebrate that we are halfway done. If we've done everything correctly, we have 50 out of 100, and that's not bad. In the next video, we're going to take a look at question number 6. Feel free to join me if that's one you are interested in seeing get done. Thanks for watching, and I'll see you in the future.